Alright, welcome to a morning video. So I'm going to keep this channel going. If I really want to pass this test, unfortunately, this channel is going to play a little bit of a smaller role, but it will still have a role for sure. The role will be hands-on. I will be in here and doing exercises on this in this lab. This is my home lab. So uh, demonstrating what I've learned and doing exercises will very much still be a part of this channel for now. Later, and then the mentoring still happens. So it's still a interesting channel to follow. I recommend it. But for now, we're just going to do a really brief summary of some of the things I've learned about OSPF. And unfortunately, I would love to do all that learning here in public, live on this channel, but I'm worried that, I'm going for a proprietary certification. So if I put too much out there in this case, I think I'd rather not. And when it came to the Juniper cert, I was really perhaps kind of brazen about it, but I made the decision with the Juniper cert not to and it made it a little bit easier on me too, because there was no official certification guide published by like Juniper Press. In this case there is, so it says very clearly in the book, you can only read small parts of it for the purposes of review, and I've done that plenty of times on this channel, but I'm going to do that less and less for each of my videos on CCNP data center, and just focus on what I've got right here in my own home lab with my own device images. So the flavor of the day for this exam is Nexus. For the Juniper, it was Juniper MX switches. So all different switch types. When you have a model of a switch, it is designed for particular networks. So when it comes to ISP, you would use ASRs. When it comes to enterprise, you would use Catalyst. But when it comes to data center, which I'm focusing on, it's all about the Nexus. So the reason I chose data center is because I believe that the data center space will become a multi-trillion-dollar industry by within 10 years, by 2035. So I want to follow the money. I feel like that's where, if you just aren't finding a lot of opportunity, it's because there's just not a lot of things happening in the space where you're trying to find it. You're not going to find water in the desert. You're going to find it in the oasis. You have to find the oasis in the desert, or even better, you should go to a freshwater lake in an area with a lot of them, Minnesota. So yeah, I'll be kind of in and out, but I wanted to make sure that I was in for some of the stuff I've learned recently about OSPF. I feel like I've really learned a lot. Particularly, I learned a lot more about not so stubby areas, and I was confused about this. I really did not understand what the purpose of a not so stubby area was. The other thing that I was really confused about was the direction of the traffic, and this is something where ChatGPT really helps. One of the best questions when it comes to understanding OSPF is, in what direction does things happen? So like, why do things happen? Why are things the way they are? Is always a good question to ask. So let's talk about this topology here, and then let's amp it up. Let's expand it out, and let's talk about more sophisticated things based on those expansions. So currently, this topology is an OSPF. Now, what is it? Anyone? It's 3, 2, 1. Tell me what it is. What it is it's an OSPF autonomous system, right? So it's a collection of networks. We've got 1, 2, 3, 4 IPv4. We've got 1, 2, 3, 4 IPv6, and we can see, these are the networks. They're labeled right there. I added an extra one here, so we have 4 networks that make up this OSPF autonomous system. Now, you might have gotten that wrong. You might have said, this is an OSPF area, this is an OSPF collection of areas, this is an OSPF domain, this is an OSPF network. If you said any of that, you were wrong. It's an OSPF autonomous system, and it's important to call it that because that's how you can understand the role of an autonomous system boundary router. And if you don't understand what that is and what that does, you won't understand not so stubby areas, because the purpose of an autonomous system boundary router is to be able to connect to another autonomous system with your autonomous system boundary router belonging to a stub area. So there you go, stated as simply as possible. I dare anyone to do that, even those who understand it well. I was not able to do that, even though I held the CCNP and the OSPF was very much on the JNCI ESP, and I held that certification, and in fact was going for the next level, the IE. So AI is changing the world. I was able to state that so clearly because I talk to the AI when I study. So yeah, it's complicated, and you have to understand what each device is. You have to understand the role they play, and you have to understand what you're looking at. So yeah, we're looking at an OSPF autonomous system. So the first thing I want to do is drop a few new routers. I want to drop a router that is going to serve as the device across the autonomous system boundary router. I want it to serve as a device in another autonomous system. So I think I'll start by dropping that. So we're going to do duplicate, and then we're going to say we're going to call it, we're going to change the host name, and we're going to call it different AS. Okay, so now we've got an invalid name. You can't use underscores in GNS. You have to use dashes. And I'll make sure to do a safety click. There we go. So change the host name to another AS like that. Okay, so now we have another AS. Now it can be OSPF. It can be whatever it needs to be. It can be RIP. An autonomous system is not. Now, when we talk about BGP, autonomous systems have numbers, right? So it's difficult to understand what an autonomous system is, and if an autonomous system doesn't have a number like it does in BGP, that creates a lot of confusion. So what is an autonomous system if it doesn't have a number like it needs for BGP connections? It's a group of devices that are administered by one entity. So you might have smaller autonomous systems that are not necessarily only through BGP. So let's say you work for Corporation A, and Corporation B is down the street. There might be reason to connect to that. There might be divisions in one company that belong would belong to different autonomous systems. So this is the other thing that gets unclear when learning this material is what means what, and what the scope of each thing is, and what the context that each thing belongs to. So I could make this very easy on myself, and I could set up a eBGP connection here, and then it would be obvious. Oh yes, these are in two different autonomous systems. But I'm not going to do that because I'm that guy. So I'm going to set up these two autonomous systems without assigning them autonomous system numbers through BGP. All right, so how can I do that? Well, I can redistribute routes. So if I'm doing another routing protocol in the other autonomous system, then that makes it very clear. I just redistribute the route from that one AS to another. But if they're both OSPF, how do I do it then? You know what? I'll be honest. I don't know. I don't know how you definitively make one OSPF autonomous system be separate from another. I know that OSPF has a limitation where you can't have a area that is not connected to another backbone area. But what I don't know is if you have an ASBR, let's say in area 5, and you can have area 5 be a regular area or a not so stubby area, and it connects to another autonomous system where they have their own OSPF group of managed devices, and they have something similar. They have area 5 here, then their backbone area. Now you're going to have this connection between the two, but it's going to be so that it's not connected to one backbone, but it would be connected to the other. So maybe that's enough. So it'd be nice to have a really deep understanding of this, enough so that this is possible. So I think that would be the goal in this exercise. But mostly I just want to see the traffic. I want to see the link state advertisements. I also want to see how the link state advertisements change when there is a designated router and a backup designated router. So to do that, I would need a broadcast network, and I would need a lot of devices in the broadcast network. Now, some of these are broadcast networks with only 2 nodes in the network. In that case, you are better off not having a BSDR, and a BSDR. I think I'm not sure where that came from. It is early in the morning, so I actually need a quick break. I'll be right back. All right, I'm back. I might have just decided to do this a bit too early in the morning, so but yeah, I think what I said was more or less true. I'm trying to learn this better myself. So we did do this already, but I'm going back and reading the book because now I have the benefit of ChatGPT. So I'm using a strategy that really centers around that. So yeah, we have a stub area. We have this. Let's start by making this a not so stubby area, and see how that changes things. So we'll have to configure this, and keep it simple. Take it one step at a time, and if you can get to a more sophisticated place by doing steps along the way, I think that's a better way to learn than not. So let's start with an eBGP connection because it makes it so easy that it lays it out all out there for you. You give the autonomous system a number. You redistribute the routes into your IGP. So there's really just no better way to do this than to use an eBGP connection, even though that might not be the way you would do it in some cases in real life. So I also want to get a good sense of what this looks like in the real world, especially in data centers, and what it would look like in modern data centers. One thing I would like everyone to be aware of in this channel is if we look at let me so what's his name? It's like he's Canadian, so it's like Canadian IT guy. Linus Tech Tips. That gives no. It's like Linus Tech. Yeah. So he talked about data centers. Yeah. So we've got a data center here. We've got so we got some videos on data centers, and I feel like, and the point I'm making in bringing this up
behind me
is that Cisco isn't the only manufacturer out there. Like, a lot of these data centers are going to be using dedicated NVIDIA cabinets. A lot of them will be using the things shown in this video. So like the Huawei is, I think, a Chinese company. So it's a mixed bag out there nowadays. Cisco used to have a lot more market share than it has now. So I just wanted to make that point. I think I'm making the right choice moving ahead the way I am, but I'm a multi-trillion-dollar space has a lot to go around, so people are going to be. It should be a place that is fairly competitive. So, all right. So we need to have this device boot up. We need to configure this as a definitive ASBR, which we can do with an eBGP connection, even though we haven't gotten there yet. And it'd be nice to drop a switch down and then like 4 networks on that switch, so we can see the effect that the BDR truly does have, and we can sniff the links, and we can see that sure enough, because it's a there are LSAs that are not being sent down these certain links. So that would be nice. That's a goal. I've probably only got another 10 minutes, maybe 15, so I won't be able to accomplish this goal in that video, unfortunately. So I guess you can kind of consider this video a bit of a keep alive video. I just kind of feel like I should put one out there this morning, but it was perhaps a bit misguided. I think doing some reading would have been a bit better. Yeah, and I've got these set up to be knocked down, so I think those would be a lot more compelling videos. And if I had done reading this morning instead, I would have gotten there faster. So I would have gotten to this example, which is on Rails. All right, but we can see my device comes up. It's not too slow. So let's drop a link. Configure a eBGP connection, and then this will definitively be serving as an ASBR in that case. I think one thing that's kind of annoying about Nexuses is if you want to do something, you typically have to enable it as a feature. So, and you know the reason for that, right? Is so that you have to pay if you. It's the video gaming microtransactions, but implemented like this. Okay, so as I said, there's a mixed market out there. There's devices that don't do that. I don't think. I mean, there's always going to be licensing, so it's definitely not fair to say that you'll find a manufacturer that won't do that at all. All right, so this is another AS. So let's call this router BGP 2. I'm gonna say neighbor, and let's do this 92.168.0.1 will be the neighbor. Pure AS. So the remote AS will be AS1. All right, that looks good. And then interface Ethernet 1/1. There we go. And then IP address 92.168.0.2. 5.5.0. No shut. I think that's probably all that is needed. The configuration is actually quite simple. Alright, but it's definitely needed to configure the other side. It also would be nice to configure a host name. Alright. Now this is different from OSPF. This is the autonomous system, and we're going to go with autonomous system 1. It's not the process ID as far as I understand. But we'll get there. I'm not there yet. Alright, so we don't have a neighbor coming up. Let's try to ping the other side. Okay, and I think where I went wrong is I was in fact wrong about that. That is the process ID. So we don't have the local AS configured, and that's why it's not coming up. But I'm pretty sure that's how I remember it working. Maybe because there's no router ID. Maybe it's shut down. So So we'll try that on both sides, router ID, and then shutting it. Huh. I thought that would be enough. Okay. Why is that not enough? Um, huh. You know what? I just kind of jumped into this plan brazen without a care for the world. I feel like it was a bit too much, especially since I'm doing it at the expense of the reading, which is going to be more important. So, I guess I'm going to hang it up, it's already been a half hour, so not sure why I can't get this connection to come up. So yeah, I'll leave it at that. And I'll come back later, maybe later today. And at some point, I did legit learn a lot more about not so stubby areas, about autonomous system boundary routers, about the role of a designated router and a backup designated router. So I'll share all that on this channel, but just not now. So thanks for watching, and see you in the next one.